motion, and direct enforcement system. The direct enforcement system consists of weigh and motion inspection station and monitoring center through PL private line or internet. The monitoring site is composed of data acquisition equipment WIM sensor, ground loop, HD camera, smart ball camera, and data manipulation equipment WIM controller, vehicle detector, hard disk, video, front-end equipment manager, and information display equipment, etc. Monitoring center consists of application server, database server, management terminal, HD decoder, display screen hardware, and other data platform software. Each monitoring site collects and processes the load, license plate number, image, video, and other data of the vehicles passing on the road in real time, and transmits the data to the monitoring center through the optical fiber network. Weigh and motion system working principle. This is the schematic diagram of the working principle of the weigh and motion station. Dynamic weighing utilizes load cells laid on the road to sense the pressure when the vehicle axle pressure on it. When vehicle drive in the ground loop installed under the road, it is ready to be weighed. When the vehicle tire contacts the load cell, the sensor begins to detect the wheel pressure, generates an electrical signal proportional to the pressure, and after the signal is amplified by the data matching terminal, the axle load information is calculated by the weighing controller. While vehicles left the ground loop, the WIM controller calculate the number of axles weight and vehicle gross weight, and the weighing is completed. Sent this vehicle load data to front of manager equipment. While WIM controller can detect both vehicle speed and vehicle type. Vehicle license plate recognition use HD camera to capture vehicle images for license plate number recognition. When the vehicle enters the ground loop, that triggers HD camera in the direction of the front and rear of the vehicle to capture the head, back, and side of the vehicle, at the same time, with the fuzzy recognition algorithm to get the license plate number, license plate color, and vehicle color, etc. HD camera can also assist in detecting vehicle type and driving speed. The integrated ball camera installed on the lane monitoring pole collects the vehicle driving video data in real time and sends it to the monitoring center. Data processing and storage subsystem receives from WIM controller subsystem, vehicle license plate recognition or capture subsystem, and the vehicle load data, vehicle image data, and video data of the video monitoring subsystem matches and binds the vehicle load and image data with the license plate number, and at the same time judge whether the vehicle is overloaded and overrun according to the load standard threshold. For the overrun and overload vehicles, the license plate number and overload data sent to the variable information board display, reminding and inducing the driver to drive the vehicles away from the main road and accept the treatment. The management department can set vehicle overload and overload monitoring points on roads and bridges according to management needs. The typical equipment deployment mode and connection relationship in one direction of monitoring points are shown in the following figure. 1. The integrated intelligent ball camera collects the road video information of the inspection point in real time, stores it in the hard disk video recorder, and sends the video stream to the monitoring center in real time for real-time display. 2. When there is a vehicle on the road entering the ground loop in the front row, the ground loop generates an oscillating current, which triggers the license plate recognition or snapshot camera to take pictures of the front, rear, and side of the vehicle, and at the same time informs the weighing system to prepare to start weighing. 3. When the vehicle wheel touches the WIM sensor, the quartz pressure sensor starts to work, collects the pressure signal generated by the wheel, and sends it to the weighing instrument for processing after being amplified by the charge. 4. After the weighing instrument performs integral conversion and compensation processing on the pressure electrical signal, the information such as the axle weight, gross weight, and number of axles of the vehicle is obtained and sent to the industrial computer for comprehensive processing. 5. The license plate recognition or capture camera recognizes the license plate number, license plate color and body color of the vehicle. The results of the identification and the photos of the vehicle are sent to the industrial computer for processing. 6. The industrial computer matches and binds the data detected by the weighing instrument with the vehicle license plate number and other information, and compares and analyzes the vehicle load standard in the database to determine whether the vehicle is overloaded or not. 7. If the vehicle is not overloaded, the above information will be stored in the database and sent to the monitoring center database for storage. At the same time, the vehicle license plate number and load information will be sent to the information guidance LED display for vehicle information display. 8. If the vehicle is overloaded, the road video data within a period of time before and after the weighing will be searched from the hard disk video recorder, bound to the license plate, and sent to the monitoring center database for storage. Go to the information guidance LED display to display the vehicle information and induce the vehicle to deal with it immediately. 9. Statistical analysis of on-site monitoring data, generating statistical reports, providing user inquiries, and displaying on the large splicing screen. At the same time, the vehicle overload information can be sent to the external system to facilitate law enforcement processing. There are internal and external interface relationships between the various subsystems of the direct enforcement system for vehicle overloading, as well as between the system and the external monitoring center system. The interface relationship is shown in the figure below.